Hello, I'm Keshav. I'm pursuing my BE.Sc. 7th semester at BMSIT. I'm working along with my team members Paul, Bhargav, and Shashandan. So we are doing the final year project named a system of IoT devices to prevent overloading and underloading of railway wagons. We are doing this project under the guidance of Bharti ma'am, who is an associate professor at our department CSE. So our project is actually based on overloading and underloading. And this is actually pertain towards railway wagons. So overloading actually occurs when the goods in the railway wagons are being transported at beyond the specified uh, threshold capacity of the wagon, and underloading actually occurs when the goods are being transferred at a level which is below the specified threshold and level. So these threshold limits are actually set by the government, by the railway authority before the goods are transferred. We know that our country boasts itself of a very well connected and a systematic organized network of railways. So where various raw materials like fertilizers, coal, oil, and various other fluids, petroleum, and thus various other raw materials are transported from source to the destination. So, but overloading and underloading actually cause a lot of problems, and they really lead to incurring huge losses. There was an incident in 2022-23 in our country. So when Coal India Limited had thought to transfer coal from a source place to destination place, the stipulated budget for doing this transportation was about 276 crores. But unfortunately, because of overloading, there was a loss, and then the expenditure of this particular project had gone up to 593 crores, which is a huge loss. So we are trying to mitigate this problem with the help of a system of IoT devices. IoT promises a good solution to this problem statement, as it is indeed cost effective, and it provides a very good wireless connectivity and scalability to improve and mitigate this problem. So let's go to the proposed methodology as to how this solution could problem could be solved.
Our solution comprises of a load cell which is connected to the bottom edge of a wagon, which is then connected to an Arduino UNO HX711 amplifier. So this amplifier takes in the measurements of the electrical impulses converted by the load cell and amplifies them to be transported to the Wi-Fi module that provides the wireless connectivity to be shown and displayed on a web dashboard, which includes a meter that provides the information if the goods have overloaded or underloaded the specified limit. So thus the overloading and underloading data is shown on the web dashboard. The load cell converts the pressure that has been exerted by the load inserted on it into electrical impulses, and that is transferred throughout the system, which ends at a web dashboard. Now let's have a look at the components that we are using in this. So this is a load cell. The load cell consists of 4 sets of jumper wires that are attached to it. And then the load cell is actually always used on a foundation which is used. So here we are using a foundation which is a PVC box. So that is made up of a plastic material. And it is about 6 into 4 area, 6 inches long and 4 inches wide. So the load cell could be fit upon this to have a good support as a foundation. So here we have fitted 2 screws that are into the holes, and then the fitting is done in this way. So that we fit at the end where the wires are attached, and to the above and to the other set of screws we increase the height by the help of nuts, to which the platform would be attached, and it is on this platform, which is placed above this, that we place the loads and test our weights. So this load cell is of a capacity of about 10 kg, and it can do the weight measurements. And the whole setup would be set up on this breadboard, on which various devices could be fit. and it is made up of a rubber sheet material that provides the necessary insulation from the electrical impulses. The load cell is connected to a HX7 amplifier, which looks like this. So this has got 4 terminals, which include an A positive and A negative sign that are the poles for connections. So in order to connect this to the 4 set of jumper wires that are located on this load cell, we need to do the necessary soldering. The soldering could be done with the help of attachment via the connections made by this connector onto the HX7 amplifier, or they could be directly soldered onto the terminals which are located over here. So load cell and HX7 amplifier are always an integrated system, and so this integrated system is then further connected to an Arduino Wi-Fi module. So this Wi-Fi module provides the wireless connectivity between the hardware and the software. So after being connected to the terminals of the Arduino module, so this is further connected to the system with the help of its port. So we use a micro cable to connect it from here onto the system. So all these connections are made by jumper wires like these, and we use them in 4 sets. And after the system is connected, so it is connected to the web dashboard. So where an IoT application is actually used, the platform would show the measurements whether the system is overloaded or underloaded. The threshold points are fit onto the system, and then we use embedded C program, which is integrated in the web dashboard, and then the indications are made. And after the limits are found and the indications are determined, so based on the results obtained, alerts and notifications are passed on to the necessary authority. So we are still working on this, it's in process. So we have the components ready with us, and we'll be carrying out this in the further days. Thank you.